So I'll do the transition myself. Hi everyone. Thank you for the previous speech. So now the next presenter is Vigram. Oh, that's me. Okay. So first of all, welcome to the speech of Vigram. I have two questions in advance. So first of all, who of you guys is doing infrastructure projects? Like streets, utility. Okay. Who is familiar with drone technology? All right. Michael, I knew it. Okay, good. So the company vigram has developed something which enables users to do smart documentation. Of course, we don't claim smart documentation just with our solution, but we have something which might help the teams on site and in the end also the asset owners and the contractors. A bit about myself, I'm in charge of the partner management organization, and our company is based in Germany. So what we provide, what we manufacture is in the highest quality standards. And why am I speaking here? Because in Germany there is, I'm going to tell you a story about one of the biggest digital-only infrastructure projects in Germany, which is the B29. And the B29 was provided by the Ministry of Transportation and Traffic, and together with our engineering office, which is GScan. And the reason behind it is that starting from 2025, there are only digital or BIM projects allowed in that area, in Baden-Württemberg and also in Bayern. And with that, next to 8 other BIM projects, they wanted to give more and more proof of concepts to the different people in the construction industry how a digital project should look like. And to enable different people who are interested in how to actually do a BIM project, there was something created which is called the BIM Lab. And the BIM Lab is something which you see here in the middle of the infrastructure project. And we invite, or our engineering company invite different people within the infrastructure sector to get acquainted with the different digital solutions which are used in that digital-only infrastructure project. And the idea behind it, I know this image or this concept is used very often, getting rid of the paper. And one specific target, and sorry Michael for saying that, but surveyors are a very rare resource, and getting them out for doing the documentation is often the bottleneck when it comes to doing the documentation and then the invoicing process. And loss of time because of that can be quite expensive. So the next thing is, one more sentence there. You see these kind of technologies, 2 people, not everybody can use this, and actually it's important to have them. And then we are also speaking about site meetings where people need to be on site for checking all the forms, doing the documentation, and in the end also the handover process. So needing all the people on site, being there in order to doing the documentation is very time and cost intensive. And there is a study which says that about the same issue, there are around about 5 images about the same issue captured on site. So let me show you how we do smart documentation in that project. So we use drones, which is flying once per week to get a bigger picture. The second thing, there are also crane cameras which they have used. The scope is a bit limited, but twice per day after lunch and in the end of the day. It's getting even better. And now something which I have in my hand, which is the vidoc. I will explain a bit more about it. it's used almost twice per day by the foreman, and I will explain why. So the foreman is creating his own as-built documentation without the surveyor on site. And there are some smart excavators who are doing as-built or 3D scans while they're driving over there. So we have tried different approaches just to get to the point where we have an as-built model. And we came to a point that two technologies are very easy to use, and we can expect a good result to come out. On the one hand, with a drone, for big scale 3D scans, and of course the vidoc in the end. The vidoc is, let's say, the device which the foreman can put in his pocket in the end. So he puts it like that, he takes it out, connects it with his smartphone, and then he is doing precisely what the drone does. He creates an accurate georeference 3D model without the necessity to have a pilot on site. All right. So in the end, that's an example of what comes out in the end. The drone and local scans with the vidoc, and you can then merge both. And the idea behind it is that everybody has a smartphone, and tuning it up for being high accurate up to 1 centimeter is then what we provided to the users on site, so that they are independent from the surveyor in the end. The surveyor comes out for high accuracy, like 30 millimeter. But day-to-day documentation, the foreman can do that themselves. And so on the one hand, the 3D scanning part is one part, but also single point measurements. And mostly surveyor come out to measure one single point. It can be done with a smartphone by the people on site themselves. So how does it work? You walk with a vidoc over that particular part which you have built. You do a 3D scan, and it captures automatically multiple images, one after another, like hundreds, like 200, 300. And then it goes to the processing. And in processing, it will then be merged to a geopositioned 3D model. Another thing is you're able to also create pictures, but these pictures are then located at the spot where the laser is targeted and not where the smartphone is positioned. Because when it comes to, in the end, for evidence, and you want to have the images to be verifiable. So therefore, the front laser gives you the position of the object which you want to document with the position of it. And last but not least, the classical GNSS rover. That's what we pay hundreds and thousands of euros for the surveyor to come out to measure a single point. You can just use your vidoc for it. And just to give you an example or an overview about how this merged into the entire software universe, in that particular project, B29, which we give as a reference project inside the BIM lab for all the people to know how a digital-only project should look like. So the core foundation of it is the VDC manager and the CD infrastructure. And then, of course, somebody has created these 3D models. Then we also have the project and bid management and bill of quantity software. And then the people on site with a vidoc and with a drone. That's what formats can use, and that's what the people who have a pilot license can use. They're interacting with each other. So you produce data on a daily basis, then you align it with a 4D and 5D simulation within the BIM management software. That's in the end VDC. And if there are any issues which have been observed on the job site, you then make sure that you have the right process for it, so that they are solved and documented how they have been worked on. And there are certain exchange formats. I don't want to go into detail, but just to let you know, there are some bridges between them. And coming from the building information perspective, the question is, what do I actually do with it? So there are main use cases which we address, and the core, or coming from the building information perspective, is we want to make sure to have a smart way of doing construction progress documentation, and not only how it is supposed to be built, but literally merging it with the perspective how it actually has been built, because on the job site there could be something in the ground where you have to get along, and then you want to make sure to have the precise position, therefore georeference model. And coming from that perspective of creating high accurate models, you then also benefit when it comes to quantity estimation. Michael has explained with the drone, you fly over the drone and then you do within the point cloud platform, you can check how much quantity of, how much volume of sand has been taken out of the ground. You can also do it with a vigram without flying over the drone, because in many regions it's hard to get the flight permission, especially when you're building near airports or when traffic is going on. Then the other thing is operation and maintenance. You want to make sure when, in the end, the operation and maintenance is done, that you have the right data of the model, how it was actually built. And last but not least, the handover and issue management. So many questions and so many arguments happens because somebody said, yeah, I built it this way, and in the end you find out 90% was actually built and 10 not. 10% was totally different, but you cannot prove that. So therefore, working with as-built document or models, all this negotiation, these arguments, they are history. Let me give an example. So that's the VDC manager, people should know it. And you have the 4D, 5D simulation ThinkProject product, if somebody hasn't seen it yet. So we use that's from that project which I've mentioned, B29. And on specific dates, for example, we want to check if we're still in time or we are in delay. So what we do is we go to a specific date and check like if that's where we should be on a particular date. We can then select, okay, today is this date, show me what should be built, this one, all right. And then you go outside, ask the people, hey, from that area, please make a 3D model and send it to me. And then he does this, and then you know it has been built or it hasn't been built. If you have a clear as-built documentation. So you merge what's supposed to be built with what has been built, and you don't have then a 3D model, you have a reality model. And then, of course, if there's a delay, you can just mark that particular part in the VDC manager. At least that's how we do it over there. And then issue recording, I mentioned that by having the precise position of the issue, yeah, saves you a lot of argument in the end. Especially if it gets in front of the court. And building and surveying, Michael, that's yours. So in the end, you just, as with a stockpile which you record with a drone, you can also do it with a vigram. And then, depending on what kind of point cloud management software you have, you can then calculate it, go back to VDC Manager, and in this particular service, you just type in how much quantity has been excavated. But you know it from real data and not from points which the surveyor stakes out and in the end calculates himself. Especially when it comes to volume, there's a lot of cash involved, or money. And there's always a tolerance, at least in Germany, of 20%, where when you don't have a 3D model, the invoicing can be reduced by 20% because of the tolerance which is accepted. Scaling it up to the revenue which you do in 1 year, it could be a lot for a construction company. And in the end, that's what comes out. On a daily basis, they do it twice per day. They scan it, the foreman scans it, and then contributes to the 3D model. I don't want to extend my time, but if you have questions, we have a booth upstairs together with our British and Portuguese distributor Turent, together with Jorvik Design Group. Before we came into the British market, Charlie and his team from Jorvik Design Group has taken care of everything meets the British standards, so that now it's part of the serving and documentation process in their projects. Thank you very much for your attention.